So today we are going to discuss first three questions of Codeforces Round 860 Div 2. So starting with first question.
So in question number A, we have given two arrays. Just suppose we named it as A and B. So what is given here means we have to do some operations such that the last elements of both the array become the maximum element of that particular arrays. Okay, so but the thing is that we will have to focus on the last element, right? So last element, and that should be the maximum of that particular array. So if I make you understand by the test cases, so let's start with test case number 1. So okay, so in test case A, test case number 1, we have given the size of the array 3. This is just suppose array A, this is array B, and the elements given are 7, 9, 7, and in second one is 7, 6 and 9. So if we think that we want that the last element of each array should be the maximum of that array, okay, so how can we think for this? So means what I thought that we can make both arrays in such a way that just suppose I compare at index 0, this is index 0, 1 and 2. So I will make array A and B as following. So now I am comparing this 7 and this 7. So since both are equal, so no issue, there is no need of shuffling. But here 6 and 9. So I want to make B as the minimum array, means at each index I will store the minimum element in array B and the maximum element in array A. So here 6 and 9. At the index 2 there is 7 and 9. So I want to make array A as maximum array. So the maximum element among 7 and 9 between in will be in array A. So 9 will be here and 7 will be here. So now if I see that in array A at the last index I am able to get the maximum element among the array A. So array A after this swapping looks like 7, 9, 9. 9, and B looks like 7, 6 and 7. So at the last index 9 and 7 is the largest among the array. So if I take another test case, just suppose I take this one 9. So I am taking a test cases that is 1, 2, 3, 4, 5, 6, 7, 8, 9. And here 9, 9, 9 and 6, 6, 6. So this is A, this is B. So as I have told you earlier that I want to make array A as the maximum array and array B as the minimum array. So let's stick to that condition. So comparing at index 0, 1 and 9. So I want to make array A maximum, so I will put 9 there, 1 here. The same way I am doing at each index. So this looks like this. So now till here it is good. At 6 and 7 we can see that 7 is already higher, so it is present there, and 6 is here. Again at 8 and 6, 8 will be there, 6 will be there, 9 will be there, 6 will be there. So we can see that at the last index of array A, 9, which is the largest among the all the elements present in A, and at the last index of B, we are able to get the maximum element of the B. So the thing is that we will have to make an array, means any of the array in which we are going to store the maximum element at the given at the particular index, and in second array we will be storing the minimum element. So, and if the condition given is that if we are able to get the last element as maximum, then our answer is yes, otherwise no. So let me show you the code. So if just okay, so in this we can see that this is simply the t, the number of test cases, here n, the number of elements present in both the array. So I have used vector, it is similar like array, so it is not a big deal. Again storing the elements in vector 1, here vector 2. Now I will start checking that condition. Here I have written that we will make the array 1, or you can say vector 1 as means maximum, where I am storing the maximum elements in there. So here that operation takes place, and after that I am means simply checking that means a variable ma in which I am storing the maximum element among the array 1, and in variable mb I am storing the maximum element of array 2. So if the last element of array 1 is equal to ma and the last element of array b equal to mb, then our condition satisfied and we will output as yes, otherwise no. So any doubt in this question? Hello. So I hope you are able to understand it. So let's start with question number B.
So coming to question number B, it says a lottery round is held for m days, and on each day there is a winner, and on each day suppose n participant. So the winner of this rounds is not allowed to participate on the next rounds. So what we have to find here is the list of possible winners on each days. So our input is initially the number of days on which the lotteries are held, and then you are given for each day the number of people that participate in the lottery and the people that are participating in the lottery. So here if you have 3 days, on the first day 4 people are participating, their numbers are 1 to 400. On the second day 3 people, and on the third day 2 people. So this was the question. So how we'll do this is, we know that the winner of present round will not participate in the next rounds. So we can say that if there is a person who hasn't participated in the rounds next to the current round, he can be a possible winner. So for this reason it will be a better idea to come from last day to first day, that is m day to first day. So what we can do is, I'll explain the first one. Okay, so the first test case was 3 days, 4 people on the first day, 1, 2, 4 and 8. 3 people, 2, 9, 1. 2 people, 1 and 4. So as you can see, 1 and 4, on the last date all the members can be winners, because uh, they will anyways be not participating in the next round. So what we can do is, we can pick the first element as we can pick the last element who hasn't participated in the previous rounds as winner. So what we can do is, we'll go to 4th first, because we are coming from the nth day, that is the last day. We know that we haven't encountered 4 anywhere till now, so 4 can be winner. Now we'll move to 1. On moving to 1, you know that 1 also hasn't participated on the previous round, so even 1 can be winner. So let us assign 1 as our winner of this round. Now we'll move to the m minus 1th round. You know that, and the participants whom we have encountered, will store them in uh, some some kind of hash array, which will store the count of each number that has appeared. So what we can do is, we can make an array named count, and count of I will store the number of times I has appeared till now. Number of times I has appeared till now. So this way we'll move to the 3rd day. We know that 1 has appeared before, so 1 cannot be the winner of this round. 9 hasn't appeared, so 9 can be, and 2 also hasn't appeared, so 2 can be. We'll assign 2 as the winner. Then coming to the first date, 8 hasn't appeared previously, so 8 can be the winner. 4 has been encountered, so 4 cannot be the winner. 2 has been encountered, so 2 cannot be the winner. 1 has been encountered, so 1 cannot be the winner. So this way we can tell that the winner of first day is 8. How will we do this using code? Let me explain the code for this. Yeah. So first we'll take the input. First we'll take the input in a 2-dimensional array. Like, you can think of this as a 2-dimensional array for those who don't know what vector is. And on the mth day we push the number of people that we have encountered, and this is let this answer of m be the final list of winners of ith day. That is, answer of I will store the winner of ith day. So since we have to come from m day to first day, we'll start from I equals m minus 1. That is the winner of m day. Initially let us assign our winner as -1. That is, we don't have a winner right now, and we'll traverse the people who have participated in the ith day. That is, these people have the people in V of I have participated in the ith day. So if these participants hasn't been encountered previously, you know that the count of the participant will be 0, because that means we haven't encountered that participant till now. So we'll assign our winner as that participant J, and we'll increase the count of the participant by 1, because you have encountered this participant, so you will have to increase the count. Count stores the number of times you have encountered the participant. So you'll assign, if count is 0, J can be the winner. Now if you don't have a winner in mth round, that is mth day, your winner variable will still be -1. So if winner is -1, it is not possible to have a winner on each day. So let us make this pause as 0, and if winner is not -1, you know that the winner of ith day is, you have found the winner of ith day. So this answer of I stores the winner of ith day. And if you don't have a winner, you will change possible as 0. Initially we have assumed possible to be true. So if you cannot have a winner, then possible will be 0. And when you cannot have a winner, you have to output -1. So that's what we are doing here. And when you have winner, you can just output the winners of 0th day to mth day. That is stored in our answer of I array. That is, answer of I stores winner of I plus 1 day. So this is what we are doing. Is everyone clear with what I've said, or is it not clear? Okay, no reply. I guess everyone is clear then. We'll move to the CH question.
So now let's discuss question C. So in question C, we have a store which sells n types of candies, which are numbered from 1 to n. One type of candy, candy of type I, has cost bi coins. In total, there are ai candies of ith type. Now we have to pack the candies in packets, and each packet should contain only one type of candies. We can't mix candies together in a packet. So if we are going to and those divisions should be equal. That is, if I am dividing candy of type A into packets of in 3 packets, then then the number of candies in each packet should be the same. We will denote it with d of I. So each packet which will contain di candies, and total number of candies is ai. So di should be a divisor of ai. More formally, it would be ai when we divide ai with di, the remainder should be 0. And the overall cost of packing the candies of a packet of a the overall cost of packing of one packet of candy of type I will be bi times di. That is cost of one candy times the number of candies in one packet. So if a packet of contains ith type candies, then the cost of one packet would be bi times di. Let us denote it with ci. Now after packing, we have to place these candies in a shelf, and we have to take in consideration that the order in which the candies are given, that is, first candies of type 1 should be stored first, then candies of type 2, then candies of type 3, and then candies of type 4, and so on. So if after dividing the candies in different packets, if the cost of one packet of one type is equals to a cost of a packet of next type, then we can keep them in same tray or under same label, under same price tag. So in the given example, as we can see, we have divided the first type of candies into 5 packets, each containing 4 candies, and the cost of of a packet of type 1 will be 12, as b of 1 is 3, that is, cost of one candy is 3, and there are 4 candies in each packet. So the overall cost of first packet of type 1 would be 4 times 3, which is 12. Similarly, for the second type of candy, the cost of one candy is 2 and the number of candies we chose was 6 in one packet. So the overall cost of one packet of type 2 would be 12, and we can place this type 1 and type 2 under same label, that is 12. So now we are asked to minimize the number of labels that would be required to place these candies. So for doing that, let me open N tab for explaining you what we'll be doing. So we are given AIs, BIs. Now we have to now let us say that we are going to place the candies in a we are going to place the candies in a shelf, and let's say that it has some divisions for each type of candy. Let's say this division is for first type candy, this division is for second type candy, this division is for third, and so on. Now we have to select some labels which will be placed on these shelves, and we have to determine how many labels will be required at minimum number of labels that we will be requiring. So for that, as now in order to match two types of candies under one label, the cost of C1, if we want to match type 1 candies with type 2 candies, that is we want to keep them under same label, then C1 should be equals to C2, and to do so it would be that B1 times D1 should be equals to let's take a general case rather than 1 and 2. So if we are saying that ith type candy is kept with I plus 1 at type candy under same label, then Ci should be equals to Ci plus 1. Now for now, as you know that Ci is equals to Bi times Di, and moreover initially as given in the question, Ai should be divisible by Di. These are the two conditions that we have to keep in mind, and we want to satisfy this condition. So we can write Ci as Bi times Di, which is equals to, and Ci plus 1 can be written as Bi plus 1 times Di plus 1. Now in order, and let's say this let's denote them as C dash. Now in order for this condition to hold, C1 should be divisible by Bi and C dash should be divisible by Bi plus 1. Now the least possible cost for this will be Ci dash will be LCM of Bi and Bi plus 1. Now you might if we take any other cost, now this condition should be matched. It is minimum of C dash. C dash can have multiple values. It is equals to LCM of minimum cost would be LCM of Bi and Bi plus 1, as it is the LCM states by definition LCM is the least common multiple of Bi and Bi plus 1, that is the least integer which is divisible by Bi and Bi plus 1. So the minimum cost, that is minimum C dash, will be Bi and Bi plus 1. Now so we can take any cost which can be K times C dash as Ci and Ci plus 1, as this is both divisible, k times c dash is both divisible by bi and bi plus 1, and we can assign it with this. Now in order for, now this is satisfied when now we have satisfied this condition. Now we will be satisfying this condition, we will try to satisfy this condition. So ai percentage di should be equals to 0. So as I said that, as we have assumed that ci is equals to bi times di, so we can write it as di is equals to ci upon bi. Now it is, as we have said, that ai should be divisible by di, which is equals to ai modulo ci by bi is equals to 0. That is, ai upon ci by bi belongs to some integer. Now as ci is divisible by bi, and we can write it as ai times bi should be divisible by ci. Let me write it more formally. Let's assume that ai upon ci by bi is equals to alpha, then ai is equals to alpha ci by bi, which implies that ai times bi is divisible by ci. Now in order to hold this condition, ai times bi now this is this condition should be satisfied, that is ai times bi percentage ci should be that's modulo ci should be equal to 0. We have to satisfy this condition, and as we are considering I plus 1 too, so ai plus 1 times bi plus 1 should be divisible by ci plus 1. Now as we have said that ci is equals to k times c dash, that is k times of LCM of bi and bi plus 1. Now we have to satisfy these two conditions. So it would be optimum if we select k to be 1. If we select any other k, it will be possible that like for example, if we take an example, say ai times bi is equals to say LCM of bi comma bi plus 1, but ai plus 1 times bi plus 1 is equals to 2 times of LCM of bi comma bi plus 1. Now it would be optimal if we select k to be 1. If we select, let's say, k to be some other element, some other integer, then there are then we can't satisfy these two conditions simultaneously. So it is optimum to take k is equals to, k to be 1. Else we can't actually, if these any of these two conditions are not satisfied, then we can't choose ci and ci plus 1 to this particular value, and then if we can't manage to keep these two same to this one, so we can't actually keep ith and I plus 1th type candies together. So in order to keep these two types of candies together, so the final condition would be ai times bi percent modulo LCM of bi comma bi plus 1 should be 0, and ai plus 1 bi plus 1, these are in multiplication, percent modulo LCM bi comma bi plus 1 should be equals to 0. If these two conditions are satisfied, then this hypothesis would be satisfied. That is, ith type of candies can be kept with I plus 1th type of candies under the same label. Now we have considered only two types of candies for now. So now let's generalize this thing to to some, not to only two types of candies. Let's generalize this hypothesis. So let us assume that we have kept some candies under same label. Let's say these three are kept under label Li, that is has cost some C. Let's say its cost as C is equals to L1. Now we want to check whether we can keep 4 under this label or not. In order to do so, in order to do that, as we have seen that the conditions that has to be met, that would be AI times BI should be divisible by C, the cost C under which we are keeping that label. This condition should be satisfied. Now if we are going to add 4 to this label, let's assume that we assuming that 4th can be kept under label L1, then A4 B4 should be divisible by the cost C dash, that is cost after considering all four of them. So it has to be 0, and moreover that A3 B3 should be reduced by this cost, and A2 B2 should be reduced by this cost. A1 B1 should also be reduced by this cost C dash. Is C dash is cost considering 1 to 4 under single label. Whereas the cost that we consider over here, where C is equals to L1, C equals to L1 is the cost if we consider only from 1 to 3, keeping 1 to 3 under same label. So let's see the relation between C dash and C, that is what effect will happen to C, the cost, when we try to keep 4 under the same label. We have assumed that 4 can be kept, so let's try to find out what will be the relation between those two. So as we have seen that the minimum cost of keeping some types of candies under same will be the LCM of those types of those candies the cost of keeping some, let's say, L to R type of candies under same label would be LCM of BL to BR. Now why this comes, how we arrived to this is that we have seen that in while discussion that the cost, let me write it more properly again. So let's assume the cost of this to be C. Now BL DL should be equals to C, which should be equals to BL plus 1 DL plus 1 to BR DR, which should be equals to C. Now in order to satisfy this, C should be divisible by BL to BR. The least cost that will be satisfying this condition is C is equals to LCM of BL plus 1 to BR. So the cost for keeping candies of type L to R would be LCM of BL to BR. Now coming back to the previous case, so if we are considering first 4 candies over here, if we want to keep 4 under the same label, so the new cost, that is cost of 1 to 4 candies, will be LCM of 1 to B1, B2, B3, B4, whereas cost of 1 to 3 would be LCM of B1, B2, B3. Now if this cost C1 to 4 satisfies these conditions, that is A1 B1 percentage modulo C1 to 4 is equals to 0, that is C1 to 4 is divisible, C1 to 4 divides A1 B2, A1 B1. Similarly, if it divides A2 B2, A3 B3, A4 B4, then we can keep 1 to 4 under the same label. If any one of those doesn't satisfy, then we have to then we can't keep 4 under the same label, and we have already assumed that 1 to 3 is under same label, so we have to keep some division as 1 to 3 under one label L1 and 4 to some further case as L2. Now we are trying to find whether C1 to 4 divides these all of these or not. Now you might be knowing that if X divides a P1 P2 to Pn, then X divides GCD of P1 P2 to Pn. Now this property is a well-known property and it holds. You might be knowing about this property. So for C1 to 4, to see whether it will divide these 4 together or not, then it should satisfy the condition that GCD of A1 B1, A2 B2, A3 B3 and A4 B4 should be divisible by C1 to 4. Now if this condition satisfies, then 4 will be considered under the same label as 1 to 3, or else we can't keep 4 with the first 3 candies. So for a general case, if we consider candies from L to R, provided that given that L to L plus 1 to R minus 1 candies are under same label, then if GCD of ALBL to ARBR is divisible by C of L to R, then we can keep R under the same label as L to R minus 1. Now this condition can be rewritten as GCD of ALBL to ARBR when divided by CL to R can be written as LCM of BL to BR. If it is equal, if the remainder is 0, then this condition holds. So I think I have explained why CL to R is LCM of BL to BR over here. Yeah. So cost for keeping L to R is LCM of BL plus 1 and to BR. Now if this final condition holds, then we can keep L to, let's say it's R minus 1, and this one is R. Now if these were already under same label X, then if this condition holds, we can extend this label to the rth element too. So now for what we will do is that first of all we will consider that first element is under some label. We will see whether the second one can be put with 1 or not by using this condition. And if we can keep it under same label, if this condition satisfies for 1 and 2, then we will keep them we will consider them under same label. If it is not satisfied, then we will consider them as different labels, and we will iterate through all the types of candies, and we will see how many of them can be clubbed together under the same label or not, using this condition. Let me show you the code for this and explain it a bit in detail. So the code for third question would be is this. First of all, we will be taking t test cases, and the first we will input n, the number of different types of candies, and for each candies we will input AI and BI. AI will be the cost. AI will be the total number of candies, and BI will be the cost of one candy of ith type. Now we will store we will consider 4 variables. Previous L, that is previous LCM, we will initiate it with B of B0. Previous GCD, previous G, to be A0 times B0, new L and new LCM and new GCD. Now we will iterate through all types of candies from 1 to n. We have already considered the 0 type candy in the variable that we are already assigned them to. We are considering that they are in under one label, and we'll see whether we can add others under this label or not. So the new LCM, that is the LCM considering from the start of the current label till ith, as we have considered them as new LCM. We can simply take the LCM of till LCM of from the start of the current label to I minus 1, that is previous LCM, it stores that, and BI, if we take the LCM of both of them, we will get the new LCM, that is LCM from the start of the label to ith type of candy. Now similarly for GCD would be the GCD of A times B of type of candy from the start of the current label till the ith type, Now if the overall GCD is divisible by the overall LCM, that is the as I've shown in the formula, as we have arrived to a specific formula, that is GCD of products of AIs and BIs from L to R, when the GCD of is taken from we have arrived to the formula that GCD of AIs times BIs from I is equals to L to R is divisible by LCM of BIs from BL to BR. So new L considers stores the LCM of B L to R, BL, L being the start of the label and R being for here we are considering I, we can keep it or not, rth type inside that label or not, and new GCD is GCD of product of AIs and BIs from L to R, where L is the start of the label and R is over here the ith type which we are considering. So if these if new GCD and new LCM, if new GCD is divisible by new LCM, then we will update the previous GCD to new GCD and previous LCM to new LCM. That is, we are considering the ith type candy under the current label and we are moving forward. Else, if this condition is not satisfied, we will update the answer, we will increment the answer. Answer is initialized with 0 and it stores the number of labels that are required, the minimum number of labels that are required for keeping all the candies in the store, in the shelf. So we will increment the answer and the previous GCD will be changed to AI times BI and previous LCM will be simply BI. So and moving and we will move ahead to next type of candy and so on till the n-1 net type of candy. So at last, after performing this operation, we are also incrementing answer plus we are also incrementing answer as for example, if all of them can be kept under the same label, this loop will continue without ever entering into the else portion, and as we have initialized the answer to be 0, we have to increase an answer. This answer accounts for the final label that we have that will occur, as the final label will never enter to this else condition and will move through this if condition only. So we have incremented the answer for that and we have simply outputted the answer. In this way this is the code for solving problem C. The GCD can be found by simply using the GCD function, and LCM is simply A times B divided by GCD. So if you guys have any doubt in question number 3, you can ask. Is it clear or shall I explain some portion of it? Even if you have any doubt in question number 1, 2, 3, that is problems A, B, C, you can ask it now. I think that everyone is clear with question number 3, so we will be ending this meeting here. Thanks for joining.